Today we'll discuss about the introduction to shift registers. Okay, what are these shift registers? We'll discuss. Okay, introduction to shift registers. Yeah, introduction to shift registers. So, what are the shift registers? I think you already came across like shift left, shift right, rotate left,
Yes,
rotate
sir.
right. That you seen, no? So, in the shift
Yes.
register, one is you have SISO. SISO means nothing but serial in and serial out, serial out, and you have SIPO. SIPO means serial in and
Parallel.
parallel out, parallel out. And next you have PISO. PISO is nothing but parallel in, serial out, serial out. And next you have PIPO. PIPO means parallel in, parallel in, parallel out. Okay, these are the four shift registers you are using. So serial in, serial out means what? You are inserting data bit by bit, one bit, and you are shifting the data one bit. Okay, it can be left shift or right shift. Okay,
Hmm.
it can be left shift or right shift. Okay, whatever
Right
method
shift.
shift you are doing. And SIPO means what? You are inserting the data uh, bit by bit, serial in. Okay, and you are taking 4 bits of data at a time. If you are taking means we are using 4 bit of data, that is nothing but you are taking 4 bit of data, that is nothing but SIPO. Okay, PISO means what? So you are inserting 4 bits of data at a time, 4 bits of data at a time, and one bit you are taking out. Okay, this is CISO, and this is SIPO, and PISO. And PIPO means what? PIPO means 4 bits of data, like 4 bits of data you are inserting at a time. You are taking out 4 bits of data.
Hmm.
Okay, so mainly for the shift register you are using D flip flop. We know that. Uh, so for latching the data, okay, for latching the data, we are using D flip flop, and you know that D flip flop is nothing but a sequential buffer.
Sequential buffer. Whatever it
Yeah,
is like input,
uh,
it comes out.
it comes out. Yeah. So mainly for the shift registers, you are using this sequential buffer. Okay. Okay. First, we will discuss about SISO. What is this SISO? Serial in, serial out. Okay. SISO. Serial in, serial out means let us take. I'm using 4-bit SISO. 4-bit. I'm using right shift. Okay. Right shift. So that means SISO by using right shift. So 4-bit means you need 4 D flip flops. So this is one D flip flop. 4 D flips are required.
So generally it is 4-bit input, like 4 inputs.
4 inputs. For the 4 inputs, you are using 4 D flip flops. Okay. So let us take D3, Q3, D2, Q2, and D1, Q1, and D naught, Q naught. Okay. So
Hmm.
yeah. So this is a synchronous circuit. So as synchronous circuit, common clock is given to all the flip flops.
Okay.
Shift register is a synchronous circuit, means what? Common clock is given to all the flip flops. Just want to check whether I started the recording or yeah. So here this Q3 is connected to D2 and Q2 is connected to D1 and Q1 is connected to D naught. Okay, Q1 is connected to D naught. So here suppose data is sending serially. Okay, serial data you are inserting. Okay, let us take I am inserting 111. Okay, I'm inserting 111 and I'm taking out serially. Okay, serial out, serial data out. Okay, serial data out I'm taking out. Okay, so let us take Suppose here if you see Q3, Q2, Q1 and Q0, and next clock I am applying. Okay, so
Hmm.
here if you see initially all the inputs are all the outputs of the when initial clock when clock is 0 or clock is not applied. Okay, here clock is not
Okay.
applied. Output of all the flip flops are what? 0 only. No, output of all flip flops will be 0 only. Initial state, or we can
Initial
call as
state.
yeah, reset state. We can call as reset state, or when you are resetting the circuit, the output of means all the flip flops will be 0 only. Suppose if you are
Hmm.
applying first clock pulse, what happens? First clock pulse means this this uh, this LSB. Let us take this is LSB bit and this is MSB bit. This LSB bit will come to D3, and so Q3 equal to D3 means one will be loaded, and the remaining all are 0 only. So here you are getting Q3 is 1 and remaining all are zeros. First clock pulse. Did you understood?
Yes, sir.
Second clock pulse, what happens? This will be shifted. So that means Q2, this one will come to Q2, and so again this value will come to D3. So Q3 becomes 1. Okay, remaining all are zeros. Okay, so that means here 1 1 0 0 you will get. Okay. At third clock pulse, what happens? Again, this will be shifted. So Q1 becomes this one will come to this Q1, and this one will come to Q2. This one will come to Q2, and one more bit will come to D3. That is come to Q3. So this is 0. Okay. So here you are getting 1 1 1 0. Okay. At fourth clock pulse, what happens? This MSB will come to this side, and this will be shifted. Here Q naught becomes 1, Q1 becomes 1, and this becomes 1, and this also becomes 1. Okay. So at which clock pulse the data will be loaded? How many clock pulses are
The
required for the data loading the data?
4 clock pulses.
4 clock pulses. Suppose if you consider n bit shift register, n bit SISO, how many how n bit SISO to load into SISO
Hmm.
serial in serial out. We need how many cycles? How many clock cycles? N clock cycles.
Cycles.
N clock cycles. Okay. And what happens again? One more time, I am drawing Q3, Q2, Q1, and Q0. Okay. And next, so clock. Okay. So here at fifth clock pulse, what happens? At fifth
The
clock
clock
pulse,
pulse it comes to reset, sir. 0.
no, this will be shifted. No, so this will
Okay,
go.
shifted.
This will be
Hmm.
go. Shifting operation is starting. Okay,
Okay.
till here loading operation, loading the data.
Hmm.
Okay, till here loading the data. Okay, after that it will start shifting. So shifting means
Okay.
this one will go. Here what happens? This one will come here,
Hmm.
and this one will come here, and this one will come here, and this will be loaded with what? 0.
0.
So here you will get 0 1 1 1. Okay. At 6 o'clock pulse, what happens?
The 1 will be again shifted.
And again shifted. Again these values will be shifted. So this one will be shifted, and this one will come here. This one will come here, and this 0 will come here, and this will be loaded with
In
0.
0.
Okay, 0 1 1. Okay. And at seventh clock pulse, you will get 0 0 0 1. Okay. At eighth clock pulse, what happens? It becomes 0 0 0 0. Okay. So how many clock pulses are required to enter to we need entire data out from SISO?
8 clock pulses.
8 clock pulses. 8 clock pulses. Okay. So that means if it is n bit SISO, N bit SISO. You need how many clock pulses? 2n clock pulses.
N
2n, no? 2 fours 8, no? Okay. So this is SISO. Do you understood?
yes, sir, understood.
Okay. Next, we'll see with SIPO. SIPO means serial in and parallel out. Serial in, parallel out. So serial in, parallel out means what? So here, so you are taking so 4 bit SIPO. So 4-bit SIPO means you have 4 D flip flops, 4 D flip flops. Serial in. This is nothing but serial in. Serial in. Okay, serial in data. Common clock is given to all the flip flops as this is synchronous sequential circuit. Common clock, synchronous circuit, synchronous design. Common clock is given, and this is D3, Q3, D2, Q2, D1, Q1, and D naught, Q naught. Okay, so this is connected like this, and how you are taking the output at a time? You are
Um,
taking the output parallel out.
parallel, parallel out. Yes, sir.
Yeah, parallel out. Okay, so this is Q3, Q2, Q1, and Q naught. Okay, so so if you write this one clock and next and
Q3,
Q3, Q2,
Q2,
Q1, Q1, Q naught. Okay, so serial in data is same only. So serial first loading the data. So initially when clock is not applied, all the flip flops are zero only. When clock is one, Q3 becomes one. Remaining all are zeros. At second clock pulse, this will be shifted. Okay, this will be shifted. Here you will get one and one zero zero. Okay. At third clock pulse, what happens? One 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 zero. At fourth clock pulse, one one 1 1. Okay, at fourth clock pulse what happens, parallelly loading is happening and you are taking
hmm,
4 bits of data at a time. Parallel out is also happening.
parallel out. Hmm.
Okay, so that means at a 2n, so that means at 2n clock, if you consider n bit SIPO, so at 2n clock cycles you will get parallel out data.
Hmm.
Parallel out data, this is nothing but SIPO. So did you understood how I am analyzing this?
Yes, sir. Yes, sir. Yes,
Okay.
sir.
Yeah. Yeah. Next,
If it
next
gets 0 0, also the same thing 2n here. I mean the next 0 0 shifting.
0 0 means what you are asking?
In the previous like serial in serial out, we got 0 0 at the 8th clock pulse, right?
Yeah, it's here shifting operation is happening. No?
Okay, okay,
So here see you are loading the data at fourth clock pulse. Parallelly at the fourth clock pulse, you are taking out the data at a time.
okay.
Parallel out. This is nothing but parallel out.
Parallel out. Okay.
Okay, parallel out. Okay, parallel out. Okay, and next we'll see PIPO, parallel in parallel out.
Parallel out.
Okay, parallel in parallel, parallel in parallel out. So parallel in parallel out means here what you are doing means suppose you are connecting 4 D flip flops.
We can use only D flip flops, or we can use any flip flops. Huh?
D flip flop only we need to use for the shift registers. D naught, Q naught. Okay. Here what I am using means common clock is there. Common clock is given to all the flip flops. So here what I am doing means I am using one 2 cross 1 mux. Here I am using one 2 cross 1 mux. Okay. Here also I am using one 2 cross 1 mux. For each and every D flip flop I am using 2 cross 1 mux. So how I am connecting means here uh, so one second. So D3 I am connecting like this. D3 I am connecting to which one means 1 I am connecting. Okay. So D2 also I am connecting to 1. 1 means I1, no?
Hmm.
And D1 I am connecting to 1. And D naught also I am connecting to 1. And these zeros are there, no? Zeros I am connecting to ground.
Down.
Zeros I am connecting to ground. Okay. I naught I am connecting to ground. And there is a there is a control signal. Okay, so what is that control signal? This output is coming and I am giving to this D3. Again this Q3 I am giving as a one second, this is not D2. Here, one second. So this Q3 I am giving as a input to this mux, and this output I am giving to D2, and this Q2 I am giving as a input to this 2 cross 1 mux, and this output I am giving to D1, and this Q1 I am giving as a input to this mux, and this output I am giving to D naught. Okay, and parallel out means what? Q1, Q naught, Q2, and Q3 I am taking out. Okay, so Q3, Q2, Q1, and Q naught. Okay, so again one more selection line I am using. What is that selection line means? Here you are using load by shift bar. What is the selection line? Load by shift bar. Okay, so load by shift bar I am connecting as a selection line. Okay, I am connecting as a selection line.
A
Okay,
load.
load by shift bar or load operation or load signal I am giving as a selection line. So when load equal to
Okay.
1, what happening? Parallel load is happening, no?
Parallel load. Load equal to 0, then it is off.
It is off. Yeah, it is off. So that means parallel load is happening. After that, parallelly you are taking out. So how many clock pulses are required?
Only
Number
one
of,
clock pulse.
yes. Number of clock pulses, number of clock cycles, number of clock
Uh,
cycles to data out, okay, data at the output equal to what? One clock cycle. Okay, data at the output is one clock cycle. So this is nothing but PIPO. At one clock cycle, loading is happening and taking out is happening.
Output is also.
Okay,
Okay, sir.
okay, this is nothing but PIPO. And next we will see last one is what is the last one?
PISO, parallel in serial out.
Parallel in serial out. Yeah, parallel in serial out. Okay, parallel in serial out. Same thing like you are drawing the uh, four D flip flops. Okay, four D flip flops. So in the RTL design, we are going to write the RTL design and test bench for all the circuits, whatever the circuits we discussed in the digital. So in
Mm-hmm.
the shift registers also, we are going to discuss the RTL design, Verilog code and test bench for both SISO,
All
SIPO,
three.
all this. Yeah.
So
So
we
if
were
you are
using this Vivado.
Vivado, we are using. Yeah. Quasta sim also we can use. Quasta sim also, that process also I will tell you. So mostly using SV and UVM, we are using Quasta sim only. So when we
Okay.
start SV and UVM, I will tell you the process of Costa Sim. Mostly I will explain in the EDA playground only. Why? Because there are some steps. I will tell you the steps how to execute the your SV and UVM codes in Costa Sim. But mostly I will
Okay.
explain in EDA playground only. Why? Because in EDA playground there is like while explanation directly if you keep on run, you will get the output only. Okay.
Okay. Okay.
Okay. Yeah. That whole thing I will tell you how to activate the license and all those things. I think you
In the
told
next month we can start in the like next month we are starting Verilog, right?
yes, yes, yeah, yeah. Within this week we'll complete this is digital. Next FSMs are there and serial adder is there. It will take two or three, four classes like that.
By next week we can complete all.
Next week we can complete. So here, what I am doing means this is giving to 1 and 0, and Q3 is giving this one is 1 and 0, and this input is given to D2, and Q2 is given as the input. This is given as 1 and 0, and this one I am giving this is 1 and 0, and here also I am using one more signal. So common clock is there. This is synchronous circuit. Common clock is given to all the flip flops. So during that clock pulse, all the flip flops will be triggered. Okay. So
Mm.
here one more mm, yeah, one more selection line. This I'm giving a selection line. So this here also for this mux I am giving selection line. This is given to D naught. Okay, this is uh, parallel in serial out. No, this is serial out. Serial
Parallel
out
and
data.
serial load.
Serial out data. Okay, so this signal is nothing but load by shift bar. Load by shift bar. Okay, so when load by shift bar equal to 1, which operation will be done? Load operation will be
Normal
done.
like
Normal
load.
load parallel in load operation will be done.
Mm.
When load by shift bar
Yes, sir.
equal to 0, which operation will be done? Shift operation will be done.
Shift.
Okay. So so that means you can consider so when this is 1 means loading the data, and this is 0 means shifting the data. Okay. So
Shifting.
clock Q3, Q2, Q1, and Q0. Suppose if you are not applying any clock initially on power on reset, the output will be 0. Okay,
0. Okay.
and just if I want to load this data 111, I need to make load by shift bar. Load by shift bar, that is equal to what? 1. No? During first clock
Mm, yes,
pulse,
sir.
loading of data is happening. Okay. After that, what I need to do? So that means when load by shift bar equal to 1 means, so this whatever the loading of data is happening, this is connected to D1. So whatever this D3, D2, D1, D0 will be loaded, parallel load.
Load.
Okay,
Parallel.
and next load by shift bar, where load by shift bar equal to 0 means, so during second clock pulse what happens? Shifting operation will be done. So first clock pulse, loading of data is happened. Loading of data is happened. Second clock pulse what happens? This will be shifted.
Shifting.
So that means here it
Mm.
becomes 0. This value will
It will be
you will get
taken.
1 1. and here
This
we get 1.
one.
Yeah, so 0, 1,
Then
1,
you
1.
one
Third clock pulse 0, 0, 1, 1.
one one
Fourth clock pulse 0, 0,
0 0 0
0,
1.
1. At fifth clock pulse, what
All
happens?
zeros.
All zeros. So the data will be taken out from the PISO, taken out from the PISO. Okay. So this is about the shift registers. Any doubts or queries?
Awesome.